Hello everyone, welcome to Zoom in Data. In this AI 900 learning series, we will learn the fundamental concepts of artificial intelligence and explore Microsoft Azure AI services. This series is designed to help you understand the key concepts required for the AI 900 certification. Deep learning is a specialized area of machine learning that uses neural networks with multiple layers to learn complex patterns from data. Deep learning models can automatically learn useful representations from large amounts of structured and unstructured data. They are especially effective for complex tasks involving images, speech, text, video, and other high-dimensional data. Deep learning is a major foundation for modern AI applications, such as computer vision, speech recognition. A neural network is a machine learning model inspired by the way biological neurons process information. It consists of interconnected nodes called neurons that receive inputs, apply calculations, and produce outputs. Neural networks learn by adjusting the weights associated with connections during the training process. They can learn complex relationships between inputs and outputs and are widely used in modern AI systems. A neural network typically contains an input layer, one or more hidden layers, and an output layer. The input layer receives the features or information provided to the model. Hidden layers transform the information using learned weights and activation functions to identify increasingly complex patterns. The output layer produces the final prediction, classification, or other result required by the application. During training, a deep learning model processes input data and produces a prediction based on its current learned parameters. The prediction is compared with the expected result using a loss function that measures the model's error. Optimization algorithms such as gradient descent adjust the model's weights to reduce the loss over repeated training steps. Through many training iterations, the network gradually learns representations that help it perform the target task more effectively. Activation functions determine how information is transformed as it passes through neurons in a neural network. They introduce nonlinearity, allowing the network to learn complex relationships that simple linear operations cannot represent. Common activation functions include ReLU, sigmoid, and softmax, with each serving different purposes. Choosing suitable activation functions depends on the architecture and the type of prediction the model needs to produce. Convolutional neural networks are commonly used for image and visual pattern recognition tasks. Recurrent neural networks were designed for sequential data such as text, speech, and time series information. Transformer architectures use attention mechanisms and have become highly important for language, vision, and generative AI. Different architectures are selected based on the type of data, task requirements, model complexity, and performance goals. Traditional machine learning often requires manually selected or engineered features before the model is trained. Deep learning can automatically learn useful representations directly from raw or minimally processed data. Deep learning generally requires more data and computational resources, especially for large neural networks. Traditional machine learning can still be more suitable for smaller datasets, simpler problems, or situations where interpretability and efficiency are priorities. Deep learning is widely used in computer vision for image classification, object detection, facial recognition, and medical image analysis. Speech and language applications use deep learning for speech recognition, translation, sentiment analysis, and conversational systems. Generative AI uses deep neural networks to generate text, images, audio, video, and code. Deep learning also supports recommendation systems, autonomous technologies, anomaly detection, and intelligent automation. Deep learning models can require large datasets and significant computing resources for effective training. Overfitting can occur when a model learns training examples too closely and fails to generalize to unseen data. Training can be time-consuming and may require careful selection of learning rates, batch sizes, model architecture, and other hyperparameters. Techniques such as regularization, dropout, data augmentation, and early stopping can help improve generalization. Azure provides cloud services and infrastructure that can be used to train and deploy deep learning models. Azure Machine Learning supports model development, training, deployment, monitoring, and lifecycle management. Azure AI services provide pre-built capabilities for areas such as vision, speech, language, and generative AI. Organizations can choose between using ready-made AI capabilities and developing customized deep learning solutions based on their requirements. Deep learning uses multilayer neural networks to learn complex patterns and representations from data. Neural networks contain input, hidden, and output layers and learn by adjusting weights during training. CNNs, RNNs, and transformers are important architectures used for different types of AI workloads. Deep learning provides the foundation for many modern AI capabilities, including computer vision, speech, natural language, and generative AI. Thanks for watching this AI 900 learning video. For more learning content, tutorials, and real-time projects, stay connected with Zoomin Data. Visit our website, subscribe to our YouTube channel, and follow us on Instagram. See you in the next video.